So I just want to talk a little bit now about some considerations when you're grading with slopes. So remember that the calculation of slope is used to measure the rate of change. This can be in terrain or in any other infinite number of applications. So in this case, we're calculating slope for terrain. Slope equation is used in a lot of other areas as well. It's a very powerful tool. Contractors commonly like to use a ratio. For example, if the change in z is 6 and the change in x is 24, they may describe that slope as 4 to 21. Sometimes you may find a reference to an angle. The angle is referring to a horizontal plane and the angle at which the surface tilts from this. So as you can imagine, it can be pretty hard for a contractor to interpolate that without a trigonometry background. So typically the slope value is not very well favored. So we tend to either do the ratio one or the percent slope. You'll most likely come across this more than anything. We have in calculating slope of a surface, we assume to be of a uniform slope. So that means that the contour spacing is even. So this surface has an even contour spacing. But in reality, you're going to find that some of the contours are really close together, they're really jagged, they're irregular, they're all over the place. So keep in mind that when you're calculating slope between things, if the space between the contours start to change, you also need to adjust your calculations or the spacing of which your proposed contours need to be to match that scenario. So this method of calculating slope will still work with surfaces that are kind of a bowl shape or a hill shape. And what you would do is simply just create a series of segments of what I would call slope lines. So basically lines that connect from one contour to another for the ones that are, really close and really far apart, that are not consistently spaced, so that you could calculate all of those. So you just create either a series of tangent lines to the surface curve or secant lines that just connect the two contours together to determine the slope. This would create kind of a jagged surface, and to make the straight lines go away, we would need to kind of create infinitesimally many of them. So in other words, we have to create kind of contours in between and calculate in between there to to get super accurate. So this is actually kind of a pretty good point to make, because computers, they can actually do this for us. They can calculate kind of really infinitesimally small to get pretty accurate slope ranges. So basically, as the more of these small little lines that are created on this kind of curvilinear surface, because remember, it's either going to be a bowl shape or a hill shape if you're working with something that's irregular, a series of lines will get created, and they'll always contain some small amount of error. So as the segments become infinitesimally more smaller and smaller and smaller to conform around this kind of curved bowl or hill shape, the error will eventually approach zero, but it will never actually reach zero. So this is why we say that surfaces in Civil 3D are really an approximation to the real surface. So you'll hear that word approximation a lot. So in the next section, we will explore building surfaces. So we're not going to actually do that by hand. We're going to do it using the tools built into Civil 3D. So surfaces are going to be a dynamic, intelligent object in Civil 3D, and we're going to start to unlock some of the true powers of Civil 3D. A lot of things that we've been doing now is more kind of CAD based instead of Civil 3D based. And we'll also take a look at how to use some of the surface analysis tools to automatically extract slope information, and how to use this information to help us make better informed design decisions.